Today's lesson is going to focus on the stock system and the classical system, which are examples of ionic compounds. These two systems are used when we have metals that are multivalent or have more than one charge associated with them. So how are you going to recognize that you need to use either the stock system or the classical system? So you have to use multivalent metals. And the only way to know if your metal is multivalent, you have to go to the periodic table and look up the charge on your metal. If you notice on the periodic table that the metal has more than one charge listed, if you are naming this compound, you must use one of these two systems. All other rules for ionic compounds are followed, such as the crisscross rule, reducing charges if needed. Those basic things do not change. This is just simply identifying whether there is more than one charge associated with your metal. So we have two different systems that we can use for these multivalent metals. When do we use the stock system? Well, the stock system is used when we are going to indicate charges by the use of Roman numerals. You have to know your Roman numerals. If you do not know them, I'm going to write them down right now. 1 is just denoted by 1 line. The Roman numeral for 2 is denoted by 2 lines. The Roman numeral for 3 is denoted by 3 lines. 4 is 1 line with a V after it. 5 is just a V. 6 is VI. 7 is VII. And that's as many Roman numerals that we are going to need in using this stock system with nomenclature. A line represents 1, a V represents 5. So when you see here for 4, for example, and you see the line before the 5, the V, that's indicating that you take 1 off of 5. When you see the line after the 5 or after the V, that's indicating that you would add on 1 to V or 5. This is why we have 6 and 7 denoted that way. Okay, let's come up with chemical formulas for some of these multivalent ionic compounds. So it's very simple, actually. Creating the formula is very, very easy because you already know the charge. We're going to tell you what the charge is in Roman numerals. And then you just apply these rules of ionics. So we know that the charge is listed in our brackets beside it. We use the crisscross rule, okay, to bring the charges to the opposite elements. If you have a polyatomic ion, don't forget, use brackets if needed. And then as usual, reduce the charges if we have to. We may not have to, but we might. Cobalt-3 sulfide. So we're telling you that the charge on cobalt is +3. Okay, write it on top of the name of the element. Sulfide, IDE indicates the element by itself. Sulfur's common charge is -2. And then we're going to do crisscross rule and we're going to come up with a formula of CO2, okay, because the 2 is coming from sulfur, and then S3, that charge is coming from cobalt. We're going to go over to lead-2 carbonate. Lead has a charge of 2. We're telling you this. Carbonate, ATE, is a polyatomic ion. So that carbonate ion has a charge of -2. So those charges are going to cancel out, and we're just going to simply write the chemical symbols for everybody. Lead is Pb, carbonate is CO3, and no charges need to come down because they're going to reduce. Gold-1 oxide. So gold's charge is +1. We're telling you that in brackets. Oxide, IDE, tells us this is the element oxygen. His charge is always -2. We apply the crisscross rule and we get AU2O. Tin-4 sulfate. Tin has a charge of +4. Sulfate, ATE, is different than sulfide. So this is a polyatomic ion. We go and we look up the polyatomic at the bottom of the periodic table. We notice it has a charge of -2. We already see we're probably going to have to reduce this. So we're going to end up with a formula of SN2 bracket SO4 with a 4. And then we're going to reduce those numbers down. You have to reduce them. Do not leave them like that. To SN bracket SO4 bracket 2. Naming chemical compounds using the stock system is just a little bit more challenging. And the reason for this is this last bullet that is here. You have to know whether your formula has been reduced or not. So as we just did some examples of coming up with the chemical formulas, we see we have to indicate the charge of your metals in Roman numerals. So the only way to know what the charge is to reverse the crisscross rule, okay, and try to figure out what is the charge on each of those metals. And we'll go through some examples. And you got to be careful, because if they have reduced your charges, it sometimes can be tricky. You might make a mistake, and I'll show you how there's a surefire way to know if they've been reduced or not. So we're going to look at AUF right here. When we do not see charges listed, we know that each of those have charges of 1. So if we reverse each of those, okay, well, this is telling us that gold has a charge of +1, and this is telling us that fluoride would have a charge of -1. So you go to the periodic table and you double check these. Can gold have a charge of +1? And when you look there, you see options of +1 and +3. So yes, it can. But don't stop there. You also have to check out fluoride, because maybe it has been reduced. It can't be in this case if it's at the lowest charge. But fluoride has a charge of -1. So what we know is that this has not been reduced. These are both of the charges for each of them. And so we're going to write gold 1 fluoride. It's supposed to be a U, sorry. Let's go next door to Cu bracket NO3 bracket 2. This 2 on the outside of the brackets comes from copper. Okay, so that is the charge if we reverse the crisscross rule. There's nothing after copper, which tells us that nitrate's charge is -1 in this particular formula. You go to the periodic table and you check it out. So can copper have a charge of +2? Yep. Can nitrate have a charge of -1? You still have to check that in the off chance it's been reduced. And yes, nitrate's charge is -1. So we know that nothing has been reduced, and we're going to say that the name of this is copper 2 nitrate. Okay, so again, polyatomic ions, we use the specific name of the polyatomic. We go down to FeS, and like above in the AUF example, when I don't see numbers, I know that each of those have charges of 1. Okay, so we write it down, and then we go and we check it out. Can iron have a charge of 1? No, it cannot. Iron's options are +2 or +3. So the way to figure this out is we have to go to the non-metal. So we look at sulfur and we say, well, can sulfur have a charge of -1? And no, it can't. Sulfur's charge is always -2. So if sulfur has to have a charge of -2, what am I going to multiply both of those by to get to a charge of -2? And this is easy. You're going to multiply everything by a factor of 2, which tells us that iron now has a charge of +2, and this compound is called iron 2 sulfide. Oops. Sorry. Let's look at the last one. So we have PB bracket SO3 bracket 2. So again, we're going to take this charge of 2 and bring it back, right? So crisscross or reverse the crisscross. According to this, sulfite, SO3 is sulfite, has a charge of -1. So these are as tricky as they're going to get here, this last example, so pay attention. You go and you double check lead. Can lead have a charge of +2? Yep, it can. Lead can have charges of either +2 or +4. And this is why you can't just stop at lead. You have to look at sulfite's charge. And when you look at sulfite on the periodic table, and be careful because there's an SO3 and there's also an SO4. SO3's charge is -2. It's not -1. And so you know this has been reduced because both of those charges don't match what is listed on the periodic table. What are we going to multiply both charges by in order to get a charge of -2 on sulfite? Well, we're going to multiply everything by a factor of 2, which means lead's charge is actually +4, not +2. And so when we write out this name, we have to make sure that we have lead 4. You got to know the Roman numeral for it. Sulfite. Okay, so these are the trickiest ones where you have to double check whether it's been reduced.